GameSci.com. GameSci.com. Welcome to GameSci.com.
Hey, and welcome to the lesson on loops and flowcharts. Today we'll be looking at the while loop first. What are loops? Loops allow the repeated execution of a block of code. When I want to execute the same code 3 times or 5 times or 100 times, I want to put that code in a loop. Loops are used many times throughout video games. If you have 5 enemies on the screen, you might want to loop through all 5 and adjust their position on the screen. If you have a bag of goodies of things you've collected while you've been picking things up, you might want to loop through all the items in that bag to see if you found something that you need. Anyway, let's get on with it. Here is the while loop. We'll start with the generic or pseudocode while loop and show you a corresponding flowchart which illustrates the logic of the while loop. Okay, essentially, while this statement is true, we're going to execute a block of statements. Now I've drawn a line from the code over to the flowchart to kind of show you where the flowchart corresponds with the generic code here. While this true-false statement is true, I want to execute this code. With a true statement, it's going to come in and execute this block of code. Again, the arrow kind of shows you where the flowchart went. It came in here. The statement was true. So I followed this path and I'm now executing this block of statements. When I'm done executing that block of statements, I'll hit the end of the while loop and spin back up and do it again. And that's what this arrow is showing you. I'm going to come out of this block of statements and come up and around. I'll hit the true-false statement again. You can see on the flowchart I'm coming back into this true-false statement right there. There you have it. That is a while loop. And while this code is true, I'm going to execute a block of statements. It's true, so I come in and execute the statements. I'm following this path right here. I hit the end of the loop and I spin back up and do it again. Spin back up and do it again. Ooh, we're true again. It looks like we're going to go back into the loop and execute the block of statements. Again, while that statement is true, we're going to repeat the execution of this code over and over and over again. Spin back up to the top. Check the condition again. If the condition is true, what are we doing? We're going in and executing that block of code. You see what I mean? It can execute this code 3 times or 5 times or 100 times. If that true statement is true 100 times in a row, it's executing this block of code 100 times in a row. Fortunately, we will not be doing that 100 times. We're going to spin back up to the while loop here and change it. We come back up here and this time the true-false statement evaluates to false. When the true-false statement evaluates to false, follow the line. We are going to exit the while loop and continue on with the program. Look at the line over here. If the true-false statement evaluates to false, this flowchart is saying let's get out of the loop. We're going to spin multiple times until we hit a false, and when we hit a false, we exit the code. There it is. That's the generic example of a while loop with a flowchart. Now let's look at a real example. Here we go. A while loop with real actual executable code that we can trace. Let's start tracing this code. First up, we're going to set count equal to 0. So we're going to put the value 0 in the variable count. This is going to be what's called our iteration variable. It's going to control how many times this loop spins. Count equals to 0. We hit the while statement. With 0 in count, 0 less than 3 is very much a true statement. As a true statement, you know what it's going to do. When the condition is true, we're going to go inside the code and execute the code inside this while block. So our system.out print line will execute. You'll see in the loop appear on our output. If the statement is true, we're going to execute the code. Count equals count plus 1. That's the second executable statement within our while block. The variable count goes to a 1 now. We'll hit the end of the loop, and we know what happens at the end of the loop. We spin back up and execute the while once again. Notice the count has slightly changed. It's 1. 1 less than 3, however, is still a true statement. As a true statement, you know what this code's going to do. It's going to enter the while block and execute the code. Print in the loop once again for a second time. You can see in the loop shows up down here in the output. After printing, we'll execute the line of code count equals count plus 1. We'll adjust count to the value 2. We'll hit the end of the loop. When we hit the end of the loop, we spin right back up and do it all over again. That's what a loop does. It repeats executing the code over and over again. This time the count is set to 2. 2 less than 3 is still a very much true statement. As a true statement, you know what it's going to do. It's going to go inside and execute the loop. For a third time, it prints in the loop. We can see in the loop showing up 3 times on the output. We'll execute count equals count plus 1 and change the variable count to 3. That looks interesting, but we're not quite there yet. We hit the end of the loop and spin back up, and I have a feeling something's going to be different this time. When we get back to the statement count less than 3, here's our new value of count. It's 3. Now 3 strictly less than 3 is very much a false statement. It is no longer true. As a false statement, what do you think it's going to do? It's going to take this line and exit the loop. Basically, we execute this code while it's true, and when it turns to false, we leave or exit the loop. The loop is over. The loop is done. I'm going to go back here and point out 3 critical points when programming a while loop. The first point I'd like to make is count is what we call the iteration variable. Count is going to control how many times this loop spins. And the number one thing you must do is initialize that iteration variable. It is very important to initialize this iteration variable count. The second thing you have to do is test the iteration variable. I'm testing count, and as long as this condition is true, I will spin in the loop, and when it goes to false, I will exit the loop. The third thing you must do when programming a loop is you must be careful to change the iteration variable. Something about count has to change in the loop in order for this condition to go from true to false. There you have it. Those are the 3 things you must do to properly program a loop. Initialize the variable, test the variable, and change the variable. If you ever program a loop that isn't working properly, make sure you check those 3 points. That's it for this slide. Let's move on to the next. Let's look at another type of loop, a competitor to the while loop, called the for loop. Once again, we'll look at the generic code or pseudocode for a for loop, and we'll look at it compared to the flowchart next to it. For loop basically does the same thing as a while loop with a slightly different flavor to it. The nice thing about the for loop is the 3 things that you have to do to get a loop to work properly: initialize the iteration variable, test the iteration variable for true and false, and change the iteration variable. On a for loop, they all happen on one line of code, so you can see exactly what the loop is by looking at that one line. Let's trace out this code and see what happens. The first thing that's going to happen is we're going to initialize our iteration variable. Notice how this initialization happens before the loop starts. This line of code executes one time only before the loop starts. Then we have our familiar true-false statement. If the statement is true, we will enter and execute the code in the loop. If the statement is false, we will leave the loop. Again, I'm showing you on the flowchart exactly where we are in the flowchart. After we're done initializing, we drop down and test the true-false condition. True-false conditions always get tested in diamonds. Diamonds have these nice little points, and we can label their output. In the case of this example, we're going to assume this is going to be true. So when it's true, what happens? We're going to go inside the loop and execute the code of the for loop. When this condition is true, then these statements will execute. Notice the line here showing you This is the block of code we will be executing. Notice the line here saying when the condition was true, we're going to come inside and execute these statements. And when we hit the end of loop, you know what's going to happen. It's going to come back up here and spin through the loop again. It's an automatic. When you hit the end of the loop, it's time to go back and redo it. Notice how this line is showing you where we are on the flowchart. We have left the block of statements and we're spinning back up. Here's something interesting. When it spins back up to this for loop, it goes to the change first. It comes back up here and says we need to change the iteration variable. Notice on the flowchart where we're at. We're going to change this variable before we go back to the true-false statement. We do the change first and then we back up and do the true-false statement. Got that? We execute change first and then we do the true-false statement. And of course, we'll assume this true-false statement is true, which means we are going to enter the for loop and execute the block of statements. Our condition was true, so we execute the block of statements. When we hit the end of the loop, we go back up. Again, watch what happens here. I go back up to the for loop, and what's the first thing I execute? The change command. Let's change our iteration variable. Then let's test it and decide whether the condition is true or false. If the condition is true, we will enter the code and execute the block of statements. After we execute the block of statements, we'll hit the end of the loop and spin back up in the for loop. We'll execute the change first when we spin back up. After we do the change, we will turn around and do the true-false statement once again. This time, the true-false statement went to false. What happens when it goes to false? It's time to leave the loop. Follow this line and you will see we will exit the loop. We will hit the code after the for loop. It's important to note this line is coming in below that curly brace. We are exiting the for loop. It's time to go home. And that's it for the for loop. When the condition goes to false, it will exit the loop and you are done. While the condition is true, we will execute the block of statements. When it goes to false, we will leave the loop and continue on with the program. That's the generic or pseudocode for loop. Let's look at an actual example. Let's look at a real working code example. So let's say my video game, I'm having to keep track of the sum of something, the sum of some money that I have in my pocket, or the sum of some scoring that I've done, or the sum of the worth of everything I own. So I'm going to loop through this code and add up for the number of items I have, what is my sum total. We'll start with initializing a variable called sum. This variable sum does not control the loop. This is not the iteration variable, but it's going to keep track of my total. So sum equals 0. I'll put a 0 in my variable sum. I'll then enter the for loop, and this line int loop equals 4. Remember, this executes one time only before the loop begins spinning. I can declare the variable here if I want. Loop is my iteration variable. It's going to control how many times I spin the loop. I can declare it here. If I do declare it inside the for loop, the variable loop is only good inside this for loop. Sum is declared before the loop, so sum would be valid after the loop. Loop is declared inside, so it's only good inside the loop. I'm going to initialize loop to 4, and it's going to control how many times I spin in the loop. With a 4 in the variable, 4 greater than 1 is very much a true statement. 4 is bigger than 1. We know when this statement is true, what happens? We're going to go inside the loop. With a true condition, we're going to go inside the loop and execute the sum equals sum plus 3. Update the variable sum to 3 because we just added 3 to it. After we update the variable sum, we'll hit the end of the loop. Hit the end of the loop, we spin back up on the for loop. Now watch carefully what happens when we spin back up on the for loop. The first place we go to is changing the loop variable. Loop minus minus. Minus minus is called the decrement operator. It says subtract 1 from the variable loop and store the result back into loop. So our 4 just became a 3 because of that loop minus minus. After we change the iteration variable, we then back up and test it again. 3 greater than 1 is still very much a true statement. As a true statement, we are going to go inside the for loop and execute it again. Inside the loop, sum equals sum plus 3. Going to change our variable sum to a 6. After that executes, we'll hit the end of the loop. You hit the end of the loop, you spin back up to the for statement. What executes first when you spin back up? Changing the iteration variable does. Loop minus minus is going to decrement or subtract 1 from the variable loop. Our 3 just went to a 2. However, 2 is still greater than 1. That is a true statement. As a true statement, we are going to stay in the loop. Entering the loop, executing sum equals sum plus 3. Sum changes to the value 9. Got it? 9. Hit the end of the loop. Hit the end of the loop, we spin back up. When we spin back up, what happens first? We change the iteration variable. Our loop minus minus goes from 2 to 1. We subtract 1 from the variable 2 and we get a value of 1. Now that's interesting. Look what happens now. When I go back to check, is 1 greater than 1? That is definitely a false statement. As a false statement, it does as you expect. It's going to exit the loop. When that condition goes to false, it's time to exit the loop. We clearly have gone past the end of this curly brace. We will pick up the program from this point on and continue on outside the loop. Excellent. Remember, when the condition goes false, the loop is done. Continue on with the program. There you have it, a for loop. This thing, I believe, executed 3 times. Because this line of code executed 3 times, the variable sum had a 9 in it at the end. That's how a for loop looks. Let's look at one other type of loop. This is called the DoWhile loop, and it is different. The DoWhile loop comes with a guarantee that it will execute the block of statements at least 1 time. A for loop and a while loop will execute 0 or more times. A DoWhile loop will execute 1 or more times. We'll start with the pseudocode or the generic DoWhile loop and compare it to its generic flowchart. When it hits the do statement, it will execute this block of code at least once. And that's what the flowchart is telling you. As I enter this loop, I have to execute this block of statements. You do not get a choice. The block of statements executes at least 1 time. After you execute the block of statements, then you evaluate the true-false condition. And that's what this is showing. We'll come to the true-false statement. That's this code inside here. Remember, true-false statements always get flowcharted in a diamond because diamonds have these lovely points on them that you can label to say this is the way the program's going to go. Now let's assume this is going to be a true statement. If it is a true statement, what will happen? What will happen is it'll take out of the diamond this path and go up there. You can see the line here. We've hit the end of the while loop. The statement is true, so we'll follow this line back up to the do and repeat the code again. That's what a loop does. It repeats the same code over and over again while the statement is true. So we pop back up to the do statement. From the do statement, we always go in and execute this block of statements. You don't get a choice. Every time you reach this do statement, you're going to come down and execute these statements right here. After the statements, we evaluate the true-false condition at the end of the loop. Again, we'll assume this is a true statement at this point. If it is a true statement at this point, it will follow this arrow, go back up to the do to repeat the code. The do will drop in and execute the block of statements. After it's done executing the block of statements, it'll hit the while statement again. True-false condition, let's assume it's true once again. If it's true again, we follow this path and go back up to the do. Every time it's true, we go back up and re-execute the loop. From the do, we drop in and execute the block of statements, and then fall down to the while statement again. The while statement evaluates to true, so we're looping one more time. After executing this block of statements, we'll hit the while statement again. This time it went to false. This time it went to false, and as you would expect, it's time to leave the loop. Now I'm showing you this line here because it's taking this arrow outside the true-false condition. It's taking the false path and leaving the loop. What is a flowchart? A flowchart is a graphical representation of the logic of a computer program, and that's what this flowchart is showing you. While this statement is true, I'm going to spin in this loop over and over and over again until this condition goes to false, and I will leave my loop. When we hit the false, the loop is done. Bang. Execute the code after the loop. There you have it, the three types of loops: while, for, and do while. I generally like to do a do while loop for code that must execute once. Things like user input. If I'm going to go to the user and ask them a question, I will verify the input is good. If they give me bad input, I'll spin around and ask the question again. So do while loops are good for user input. For loops are good for fixed iterations. When I want to loop from 0 to 5 or 1 to 10 or 10 to 100, for loops are excellent. After that, I just use a while loop for everything else. Let's move on to a real code example. Here is do while with actual executing code. You can see once again our three important parts of the loop. We have to initialize an iteration variable, we have to change an iteration variable, and we have to test the iteration variable. All three critical components of a loop are in this code. Let's see how it works. We'll first start by initializing our iteration variable to count. Set it equal to 1. You can see a 1 being stored in our variable count. When we hit the do statement, we don't get a choice. We have to execute this block of code. There is a guaranteed, you must execute this code at least one time. System.out println will output the word looping to our screen, to our output console. That's what that arrow is showing you. After that, we'll set count equal count plus 2. We'll change the variable count to 3. With the value of 3, 3 less than 8 or count less than 8 will be a true statement. As a true statement, what do you expect the loop to do? Spin back up and repeat all over again. Every time this statement is true, we will spin back up to the do statement and do it again. So from the do, we'll drop down into our code again. We'll print out looping. Looping shows up for a second time on the screen, on the console. After that, we'll say count equals count plus 2. We're up to 5 now. Count less than 8 now evaluates to 5 less than 8. Still a true statement. And since it's a true statement, we will spin back up in this loop. When we spin back up in the loop, we'll drop down and system.out println looping once again. For a third time, you can see it's come out to the console. We'll execute count equals count plus 2. Count has now gone to the value 7. Dropping down to the while statement, count less than 8 is evaluated as 7 less than 8. That is very much a true statement still. 7 is smaller than 8. As a true statement, it's time to go up and repeat this code again. Every time that statement is true, we're going to go back up and repeat the code again. System.out println looping. For the fourth time, we will print out the word looping to the console. We'll drop down to the count equals count plus 2. Count has now gone to the value 9. Dropping down and evaluating the condition, count less than 8 is 9 less than 8. 9 less than 8 is a very false statement. As a false statement, we would expect to exit the loop. And that's what this line is showing you. I'm going to hit the code below the curly brace. I'm going to exit the loop. When this condition goes to false, Follow the path to get out of the loop. There you have it. That is a DoWhile loop. Let's move on and look at something else. Very related to the loop statements is the break statement. We've seen the break statement before. It was in the switch, and it said break out of the switch, stop executing the switch. Well, it turns out the break statement does the same thing for all three loops: while, do while, and for. If it ever executes a break inside of any loop, it will break out of the loop. This also gives us a good time to review the while loop and see how it works. Let's trace this code. We'll set our loop, our iteration variable, loop to 8. That'll be our starting value, our initial value. Remember, you always initialize the variable that controls the loop before the loop starts. We will then test that variable. We'll ask if loop is greater than or equal to 8. Well, that's an easy one. 8 is definitely greater than or equal to 0. So that is a true statement. As a true statement, we will go inside the loop and execute everything in this block. Between these two curly braces, everything will execute. So all of this code will execute when that while statement is true. So we'll print out system.out.println, and another loop appears on our output or our console. After that, we'll execute this if statement. If loop equal 5. Well, that is now an 8 equal 5. Loop has the value 8. 8 equal 5 is a very false statement. When this statement is false, we are going to skip past the code in the if and go straight to the loop equals line. See what this arrow is showing you? Go from the if, because it's false, to this loop equals line. Skip the break, in other words. So loop equals loop minus 1 will change the value of our loop variable to 7. After we change the iteration variable, again, that's one of the keys to writing a loop, changing the iteration variable, we'll hit the end of the while loop, and when we hit the end of the while loop, we spin back up, because that's what loops do. They repeat the same code over and over again. When we get back to the while loop, the new value 7 in loop, 7 greater than or equal to 0, is still a very true statement. As a true statement, the while loop will enter the code and execute it again. System.out.println executes again, and another loop appears on the console. If loop equals 5 is now 7 equal 5, because there's our new value in the loop variable. That is still a false statement. So once again, we're going to skip from the if all the way down to the loop equal line. Do not execute the break when this condition is false. Loop equals loop minus 1. We'll take our loop variable down to 6. We'll hit the end of the loop. When we hit the end of the loop, we spin back up to the while statement. When we spin back up to the while statement, we will evaluate the condition once again. Our value in loop is currently 6. 6 greater than or equal to 0 is a very true statement. Nothing controversial about that. 6 greater than 0 is true, which means we are going to enter the while loop once again. When we enter the while loop once again, we print out another loop. For the third time, this prints out onto our console. Testing the if statement, loop equal 5. Our current value 6 equal to 5 is still false. As a false statement, we will go straight from the if down to the loop equals line. Whenever the if is false, we skip the code in the if statement. Loop equals loop minus 1 is going to take loop down to the value of 5. We're not done yet, though. We're going to hit the end of the loop. The loop will come back up here to the while statement. When we move back up to the while statement, we test the condition again. The current value in loop is 5. 5 greater than or equal to 0 is definitely true. So what are we going to do? We're going to go inside the code and execute all the code between these two curly braces. System.out.println for a fourth time puts a fourth output to the console. We then hit the if statement and ask, is loop equal to 5? Well, we have a new value in loop. It's 5. 5 equal to 5 is a true statement. As a true statement, we're going to go inside the if and execute this break right here. What happens when we execute the break? This happens. We break out of the loop. Notice where this arrow is going. When we execute this break, that arrow is leaving the loop. I'm definitely pointing below the curly brace. I'm out of the loop. Break means do not pass go, do not collect 200. You're out of the loop. In other words, break out of the loop. We're done here. Nothing in this loop will execute after that break. It's over. Break is a hard exit from a loop. One thing you'll notice about this code, this never went false. This was true during the entire execution of spinning through this code. It wasn't until I was true on this if statement and executed the break that I left the loop. That's the break statement. Here is a related statement to it. It's called the continue statement. Continue I call a soft break. A continue allows you to stay in the loop one more time. Whereas a break is a hard exit, leave right away. A continue is sort of a soft, let's check to see if we can stay in the loop. To see how it works, let's run through the example code. I'm going to set up a variable called max. It's just going to track something for me. Max is going to have an initial value of 0. Max is not the iteration variable. Max does not control the loop. It's just keeping track of some numbers for me. With this example, we'll review the for loop and see how the for loop does. Recall that this line of code right here executes one time before the loop starts. And only one time. I'm declaring the variable CTRL or control inside the loop. That means it's only good inside the for loop. And I'm setting it to initial value of 1. That's what happens. This first statement initializes the variable that's going to control the loop. After that executes, we'll go over and ask, is 1, our control, less than 5? 1 is definitely less than 5. That is a true statement, and we all know what happens when it's true. We're going to go inside the loop and execute the code inside the loop. We reach this if statement. Control has a 1 in it, so this is 1 equal to 2. That is a false statement. Or 1 equal to 4. They're both false. When both sides of an OR are false, what happens? The result of the OR is false. So this statement evaluates out to be false. And when it's false, it will skip past the continue and go to the line that starts with max equal. Because it is false, we will skip past the continue and execute the line max equals. Max equals max plus 3. 0 plus 3 is going to be a 3, and you can see the variable max is changed when this line of code executes. We'll hit the end of the loop, and we all know what happens at the end of the loop. We spin back up to the for statement. Watch closely what happens here, though. The first thing that executes after spinning back up is changing the iteration variable. This control plus plus is the increment operator. It says add 1 to the variable and store the result back into the same variable. It started at 1 and control plus made our 1 a 2. We now have a variable in 2. Remember, this takes the current value in the variable, adds 1 to it, and stores the result back into the same variable. So with the value of 2 in CTRL, this now evaluates out 2 less than 5. 2 less than 5 is still a true statement, and we know what happens when it's true. It falls into the code. It's going to execute the code in the for block. Everything between this curly brace and that curly brace is going to execute when this is true. Now something has changed here. There's a 2 in the variable CTRL. 2 equal 2 is true. 2 equal 4 is false. but the OR only needs one of them to be true for a result of true. So this if statement is going to evaluate to true. And when it evaluates to true, we are going to take this arrow and execute the continue. What does the continue do? The continue takes you right back to the for statement. It's going to skip the max plus 3. It's going to skip this closed curly brace. The continue says continue the loop. Go back to the loop and test the condition again. It's sort of a soft break because it gives you one more chance to stay in the loop. And in this case, it is going to stay in the loop. We'll add 1 to control. Control has gone to 3. After we add 1 to control, we will skip back and test the true-false condition. 3 is less than 5. That is still a true statement. As a true statement, we're going to go into the block and execute the code in the for loop. This time 3 equal 2 is a false statement, and 3 equal 4 is a false statement. This if statement is false. When it's false, we skip the continue and go to the line that says max equal. Max equal max plus 3 is going to change max variable to 6. We've executed this code twice now, and we have 6 in the variable max. Hit the end of the loop. At the end of the loop, we spin back up and repeat the code. When we spin back up to the for statement, the first thing we do is update the control variable. The control variable, CTRL, is now 4. 4 less than 5, however, is a true statement. As a true statement, it's time to execute the for block. So we're going to go inside the for statement to the if. The if is now different. 4 equal 2 is a false statement. 4 equal 4 is a true statement. The OR statement only needs one side to be true. Since this side is true, the overall result is true. So what we have here is a true statement. As a true statement, it's going to go inside and execute the if code. In other words, since the statement above it is true, we are going to execute the continue. Since the continue says go back to the for loop and test it again, we will go backwards in the code and execute the for once again. First thing we do, plus CTRL. This is the increment operator. It adds 1 to the variable. 4 just became a 5 because of this plus. When we test the condition, 5 strictly less than 5 is false. As a false statement, what do? We exit the loop. It took this line, because the condition was false, it took this line and exited the loop. That is the continue statement. I always think of it as a soft break. It lets me one more chance to stay in the loop. In the case of this loop, when it went back up on the continue, since the condition went to false, it took the path to leave the loop. That's it for this lesson. Thank you, and we'll see you on the next one. Well, I hope you enjoyed that lesson. Once again, I'm Professor Chris Ferguson. Please visit us at gamesci.com to see more interesting lessons, courses, programming exercises, quizzes, all the fun stuff.